We're going to be going over the homework assignment from section 5.2. The problems that we'll look at in here are involved from page 174 to 175, 2 through 18 even, and 19 to 22. First, the directions in this one say, state the principal definition or theorem that tells you that SACK is a parallelogram. And the first one, you're told that SA and KC are the same length. SA and KC. And that SK and AC are the same length. And this, for this one, we would just want to say, well, it's a parallelogram because opposite sides are congruent. For me, that's what we would want to go with. If this is actually theorem 5.4 in your book. The next one, and we start over here, so we erase what we had. The next one says SO is half of SC. SO is half of SC, meaning these two things end up being equal, and that KO is half of KA, meaning these two are the same thing. So why is this a parallelogram? Because the diagonals are bisecting each other. Okay, and number 6 says, suppose you know that triangle SOK is congruent to, that was a congruency symbol, triangle COA. SOK and COA, these two triangles are congruent here. Explain how you could prove that quadrilateral SACK is a parallelogram. Well, if we look here, SO on this congruency statement corresponds to CO, which means by CPCTC, SO and CO are congruent. And KO, or OK, corresponds to OA, so these two are congruent. So this one would be just like number 4. It's because the diagonals, because the diagonals bisect each other. So it must be a parallelogram. The next one here says the quadrilaterals are numbered 1, 2, 3, 4, and 5 are parallelograms. So these are all parallelograms of the three-dimensional figure here. And if you wanted to show that quadrilateral 6 is also a parallelogram, which of the 5 methods on page 172 would be easiest to use? Well, out of the 5 methods here, we would probably say, I would say the easiest to use would be to have one pair of sides both parallel and congruent, because all of these, since they're touching here and sharing sides, we're going to have a bunch of sides that are both parallel and congruent. So we have one pair of sides both parallel and congruent. I would think that that would be the easiest way for me. Okay. Next, number 10, give the reasons for the proof. Here we have A and C are both equal to X. That was given. And then 2X plus 2Y equals 360. Now, I didn't have these in here, but these are both Y. And that's because the angles of a quadrilateral have a sum of 360. So all these add up to 360. Then we just, from step 2 to step 3, we just divide it by 2, so it's division property of equality. And then next, since x plus y equals 180, and we have, these are same side interior angles on these two lines, these being, the same side interiors being supplementary makes those lines parallel. And same thing with x and y here. So that makes these two lines parallel. So because same side interiors are supplementary, those lines must be parallel. And the reason that ABCD now must be a parallelogram is because opposite sides are parallel, and that's the definition of a parallelogram. You can write like that. To prove Theorem 5.5, we should first look at what Theorem 5.5 says, which says if one pair of sides of a quadrilateral are both parallel and congruent, so this pair right here will make them congruent, and we'll say they're parallel, and the quadrilateral is a parallelogram, I would start by drawing one diagonal, okay, and maybe labeling angle 1 and angle 2 here. Now I won't go through the whole proof necessarily all at once here, but I'll go through some key steps here to get you started. I would start by labeling all these sides here so we have something to reference. And I would probably say A, B, and C, D are congruent and parallel. That's given. And I would say angle 1 and angle 2 must therefore be congruent. And that's because alternate interior angles are congruent. And then I would probably say that DB is congruent to itself. And that's reflexive. Next, now we're looking at two congruent triangles. So triangle ABD is congruent to triangle CDB by side angle side, and that makes AD congruent to BC. By CPCTC. Now to finish up this proof, oh boy, I wasn't going to do the whole proof, but I enjoyed this so much I just kept going. To finish up the proof, we need to prove that this is a parallelogram, and since we just said that this piece is congruent to this piece, now we have both pairs of opposite sides congruent. So ABCD is a parallelogram, and the reason opposite sides congruent, both pairs. Okay, moving on here. The next proof says given parallelogram ABCD with M and N as midpoints of these two segments. So here's a midpoint, and M is a midpoint. And I want to prove that AMCN, this quadrilateral in the middle here, okay, is a parallelogram. Well, to prove it's a parallelogram, if you look here, since we have, actually, I'm going to take away these marks that I made earlier. I'm just going to get you set up for the proof here. Since we have ABCD as a parallelogram, we know this piece is congruent to this piece, DC and AB. And so when we split this in half, these two are congruent, and we also know that these two are congruent. Now, if you look at this parallelogram here, AM and C, all I need is AN congruent to MC. Okay? And then I'll have opposite sides congruent, both pairs of opposite sides congruent, so I'll have a parallelogram. Okay? So my last two steps should look like that. Because I already have, well, I'll need NC and AM congruent before that. So I'll have AM congruent to NC. Now to get, oh, sorry. This piece that I wanted here, I don't know what I was talking about. I need both of these, but I just said the same one twice. The other pair I need congruent are AN and MC. Okay, so I need this piece congruent to this piece, and then I'll have a parallelogram because both pairs of opposite sides are congruent. So to do that, I'm just going to prove that these two triangles are congruent. And to do that, I would say that AD is congruent to BC, because opposite sides are congruent on a parallelogram. And then I would say angle D is congruent to angle B, because opposite angles are congruent. And then I would do the two congruent triangles, and they would be congruent by side angle side. And then AM, and then we could easily say that AN and MC are congruent by CPCTC. So there's some key steps. Now 16. For 16, we're trying to prove that this WXYZ is a parallelogram, and we're told that ABC is a parallelogram. Since it's a parallelogram, we know DO is equal to OB, and AO equals OC. Well, since that's true, and we're told that these are all midpoints, we know that since these two are equal, we know that half of each of those are going to be equal. And since DO equals OB, half of each of those are equal. So now we're going to end up with a parallelogram by diagonals bisecting each other. And that's why that'll be a parallelogram. The rest of the problems we'll have to do in a separate video because this is getting kind of lengthy.